December 12, 1944, Tachikawa Arsenal, Tokyo. The winter air cut through the open hangar where a captured American tank sat under bright inspection lamps. Around it, officers from the Imperial Japanese Army's 4th Technical Research Group moved quietly, clipboards in hand. The machine was a medium tank M4A3 Sherman, serial number partly scorched off, captured months earlier in Leyte, the Philippines. Its 75mm gun was still locked in travel clamp. Mud from Pacific soil clung to the treads. To the Japanese, this was more than a trophy, it was a question. How had a nation that had never fought a modern armored campaign produced the most numerous and, increasingly, the most successful tank of the war? They began by stripping it. The upper glacis plate measured 63.5mm, sloped 37 degrees from vertical, mathematically equivalent to 100mm of vertical armor. The turret face, 76mm, side plates, 38mm. It was not exceptional on paper. Yet the tank had survived multiple hits from Japanese Type 147mm anti-tank guns before its crew bailed. The engineers moved to the engine compartment. There sat the Ford GAA, an all-aluminum, 60 degrees V8 producing 500 horsepower at 2,600 revolutions per minute. Derived from an aircraft engine design, it gave the 33-ton vehicle a power-to-weight ratio of 15 horsepower per ton, enough to reach 25 miles per hour on level ground. Beside it, a heavy-duty transmission, 5 forward gears, synchronized. The Japanese technicians noted the accessibility. Every major component could be removed in hours using standard tools. Chief Engineer Major Kiyoshi Ishikawa dictated notes and clipped phrases. Construction, welded hull robust. No wasted material. Simplified. He meant it as a flaw. But over days of study, the simplicity revealed something deliberate. A design optimized not for brilliance but for mass replication. By 1944, Japan had produced fewer than 2,400 tanks in total. The United States had produced 49,234 Shermans, assembled at 11 factories, including Chrysler's Detroit Arsenal tank plant, which alone built 22,234 units. The Americans had turned armored warfare into an industrial process. The Japanese compared the Sherman to their Type 97 Chiha. That tank weighed 15 tons, had a 170 horsepower diesel, and carried a 57mm low-velocity gun. Its riveted armor cracked under impact. Its crew communicated by hand signals or flags. The Sherman, by contrast, carried radios in every vehicle, Euro-stabilized guns, and optics that allowed engagement at 1,000 meters while moving. Technicians were astonished to find the Westinghouse stabilizer, a small hydraulic device that kept the gun steady when the tank moved. It was crude, yes, but unheard of in Japanese armor. The fire control system included M38 telescopic sights and a periscope for all-around visibility. When they cut open a bogie assembly, the secret was not hidden, it was simplicity itself. The vertical volute spring suspension allowed fast replacement. Each road wheel arm was held by 4 bolts. No precision machining was needed. It could be repaired in a muddy field by a mechanic with a wrench. To the Japanese eye, the Sherman was inelegant, a brute of steel and bolts. Yet when they reassembled it, fueled it with 100-octane gasoline, and started the engine, it ran smoothly. After 6 months of combat and months more of transport, the machine came alive on the first crank. The sound echoed through the hangar, deep, even, unbothered. Ishikawa stood silent for a moment before writing his final note. It is not superior in design. It is superior in purpose. That purpose had been forged long before Pearl Harbor, in American planning rooms where engineers, not generals, dictated doctrine. By the time Japan's technicians examined their captured prize, the U.S. Army was already deploying new versions, the M4A3E8 EZ-8, across France and the Pacific. The war of factories was already decided. But the blueprint for victory had begun 4 years earlier, in Detroit. September 5, 1940, Aberdeen Proving Ground, Maryland. The first prototype of what would become the Sherman tank rumbled onto the test track. The sun reflected off its unfinished steel hull, labeled T6 medium tank in white stencil. Watching from the observation tower were officers from the U.S. Army Ordnance Department, led by Brigadier General Gladion M. Barnes. The war in Europe was 1 year old. France had already fallen. Britain stood alone. The U.S. Army had fewer than 400 modern tanks. The T6 was a gamble, a machine designed for a war the United States was not yet fighting. Its layout was unorthodox for 1940. The power plant sat in the rear, crew in the center, transmission at the front. This through-drive shaft design simplified assembly and gave the vehicle a balanced center of gravity. It also created a high silhouette, 9 feet tall, but the engineers considered that acceptable if it meant faster production and easier crew operation. The T-6 mounted a 75mm M3 gun, the same weapon used in the B-25 Mitchell bomber's nose variant. The Army had learned from Europe's battlefields, speed without firepower was suicide. The French Saumua S-35 and British Matilda II had fought bravely, but their limited range and mechanical complexity doomed them. America's ordnance designers wanted a tank any factory could build, any mechanic could repair, and any soldier could drive after 2 weeks of training. On September 18, the T-6 completed its 500-mile endurance trial. It averaged 23 miles per hour, crossed 60-degree slopes, and fired 300 rounds without major malfunction. The Ordnance Board approved limited production under the name Medium Tank M4. Then, on December 7, 1941, Japan attacked Pearl Harbor. The experiment became urgent reality. Within 48 hours, the U.S. Army tank program received a production goal, 1,000 tanks per month. The order went not to a single manufacturer but to an entire industry. Chrysler, Fisher Body, Press Steel Car, Baldwin Locomotive, Pullman Standard, and American Locomotive Company each received blueprints. The Army standardized every nut, bolt, and fitting, even the wiring gauge. By February 1942, Chrysler broke ground on the Detroit Arsenal Tank Plant, the first factory in the world built solely to mass-produce tanks. Designed by Albert Kahn Associates, it covered 113 acres of reinforced concrete and glass. 6 months later, the first M4 rolled off its line. It took 5 days to assemble a Sherman from bare hull to test drive. Each plant used the same design but adapted its own powertrain. Some used the Continental R975 radial, others the General Motors twin diesel, still others the Ford GAA. The interchangeability principle meant that engines, bogies, and transmissions could be swapped between tanks in the field, a logistical miracle that no other nation matched. While German engineers pursued technical perfection with the Tiger and Panther, each taking 150,000 man-hours to build, the Sherman took 10,000. America could build 15 Shermans for every Tiger. By October 1942, the first M4S reached El Alamein, Egypt. The British 8th Army received 252 of them under Lend-Lease. Facing Rommel's Panzer III and IV, the Sherman's stabilized gun and reliable mobility changed the tempo of desert warfare. British tankers nicknamed it the Ronson, sometimes cruelly because of its tendency to burn, but they also called it the tank that always runs. Back in Washington, planners began linking the tank to a doctrine: armored exploitation. The Sherman was not built to duel heavy tanks. It was built to move, to cross bridges the Tigers couldn't, to be shipped anywhere, repaired anywhere, and used by anyone. The strategy was industrial war as maneuver. By producing one design in overwhelming numbers, the Allies could concentrate logistics, training, and tactics around a single reliable chassis. That philosophy would soon prove decisive. By mid-1943, as Japan's technicians still tested their fragile Type 97s, 17,000 Shermans were already in service across 3 continents. In North Africa, Italy, and the Pacific. And soon, one of those tanks would reach the jungles of the Philippines, to be captured, crated, and shipped to Tokyo for dissection. October 23, 1942, El Alamein, Egypt. At 21:40 hours, 882 British guns opened fire across a 40-mile front. Dust and flame rolled over the desert. The Second Battle of El Alamein had begun. In the second wave, advancing under the cover of artillery, came the newest addition to the British 8th Army, the M4A1 Sherman. Each tank carried a 75mm M3 gun, a 9-cylinder Continental R975 radial engine, and a 4-man crew. They belonged to the 9th Lancers and the Sherwood Rangers Yeomanry. Most of the crews had trained on Crusaders or Grants. The Sherman felt enormous and unstoppable. At dawn on October 24, the tanks crossed enemy minefields. They met Panzer III OSF. LS and Panzer IV Specials of Rommel's 15th and 21st Panzer Divisions near the Ramon track. German gunners opened fire first, their 50mm KWK-39 shells punching into the desert air. The Shermans fired back at 1,000 yards, their guns stabilized, their optics steady. In the first 48 hours, the British lost 75 Shermans, but destroyed over 110 German and Italian tanks. The key was not armor thickness or gun velocity, it was reliability. The Sherman stayed moving when the Crusaders broke down. They climbed dunes, maintained radio contact, and maneuvered in coordinated platoons. When the battle ended on November 4, Rommel's Afrika Korps was in retreat. The Sherman had passed its trial. It was not invincible, but it was constant. The tank that arrived, advanced, and kept advancing. February 14, 1943, Kasserine Pass, Tunisia. Now it was the Americans' turn. The U.S. II Corps, under Major General Lloyd Fredendall, faced Rommel's counteroffensive. The newly arrived 1st Armored Division fielded M4A1 Shermans alongside older M3 Lees. The Americans were confident but inexperienced. At 8 o'clock, near Spitla, German Tiger is of Schwer Panzerabteilung 501 struck. The first Tiger, number 131, hit a Sherman at 1,500 meters. The shell went through front armor and out the back plate. Within minutes, 6 Shermans were burning. The Americans learned, brutally, that the Sherman's 75 mm gun could not penetrate a Tiger frontally beyond 500 meters. Yet when the smoke cleared, logistics decided the day. The Germans advanced only 40 miles before fuel shortages and Allied air attacks halted them. The U.S. Army replaced its destroyed tanks within 10 days. Germany replaced 3 Tigers. Colonel Paul Robinette, commanding Combat Command B, wrote, "We lose tanks. They lose crews." It was harsh arithmetic, but it favored the Allies. By May 13, 1943, Axis forces in Tunisia surrendered. The Allies had captured 275,000 prisoners. The Sherman, once untested, was now the backbone of an army that could fight on 2 continents. The Ordnance Department analyzed the reports from Africa. The 75 mm gun, adequate in 1942, was becoming obsolete against new German armor. In response, on June 24, 1943, the M4A1 76W prototype rolled out, equipped with the 76 mm M1 gun, firing an APC round at 2,600 feet per second. Engineers also added wet ammunition stowage, moving shells to floor-mounted water-filled racks that reduced fire risk by 75%. Every lesson from Africa was converted into an engineering fix. The next proving ground would be Europe, where the Sherman would face Panthers and Tigers in the bocage of Normandy. But while the Western Front awaited, another theater was already demanding tanks: the Pacific. The U.S. Marine Corps had tested Shermans on Tarawa, November 20, 1943, and discovered new challenges: coral reefs, mud, and close-range ambushes. Crews improvised waterproofing kits, flamethrower conversions, and deep-wading trunks. It was one of those Pacific Shermans, amphibious, scarred by months of island fighting, that Japanese engineers would one day examine at Tachikawa. By the end of 1943, the U.S. had produced 29,500 Shermans. In the same year, Japan built 121 tanks. The war's outcome was already written in the foundries. But the next chapter would show how the Sherman's real weapon was not its gun, it was its ability to be everywhere at once. January 2, 1944, Detroit Arsenal Tank Plant, Michigan. Inside the world's largest tank factory, a line of M4A3 Shermans stretched nearly a quarter mile. Cranes lifted turrets weighing 8.5 tons. Sparks flashed from welding torches. The plant operated 24 hours a day, 7 days a week, staffed by 22,000 workers, many of them women. Every 58 minutes, a completed tank rolled off the line. The United States had achieved what no nation before had managed: industrialized war on a planetary scale. In 1944 alone, American factories produced 17,565 Shermans. Germany built 3,700 Panthers. Japan built 385 tanks of all types. But raw numbers told only half the story. The secret was how those Shermans moved. Each completed tank was tested at Chrysler's 3.5-mile track, then loaded onto flat cars bound for Newark, New Orleans, or San Francisco. At the docks, Army engineers fitted them with Costco deep-wading trunks, snorkels allowing fords up to 7 feet deep, and sealed engine decks with rubberized tar. Every Sherman had to survive saltwater, humidity, and the shock of landing craft drops. At Newark port of embarkation, stevedores lashed tanks into the holds of Liberty ships. Each ship carried 60 to 70 tanks, plus spare parts, ammunition, and rations. By March 1944, more than 1,200 Shermans per month were crossing the Atlantic, bound for Bristol, Liverpool, and Cherbourg. Others sailed west across the Pacific to Noumea, Guadalcanal, and Saipan. No other nation matched this logistical reach. April 10, 1944, Brisbane, Australia. A ship named SS John T. Holt docked at Pinkemba Wharf. In its hold, 76 Shermans for the 1st Marine Tank Battalion. Within days they were refitted with flamethrower turrets, nicknamed Zippos, for the coming assault on Saipan. Meanwhile, in Britain, depots at Tidworth and Lulworth Cove modified Shermans for the European invasion, fitting duplex drive (DD) systems, collapsible canvas screens and propellers powered by the tracks. These swimming tanks would lead the assault on D-Day. The DD Sherman could cross 4,000 yards of open sea at 4 knots. Of the 306 launched on June 6, 1944, 80 reached the beaches, enough to support the infantry landings at Gold, Juno, and Sword. On Omaha Beach, many sank in rough water, but those that landed cleared the exits within hours. This was the Sherman's true advantage: mobility of system, not just of machine. A tank could be built in Michigan, tested in Maryland, shipped through Panama, and fighting in Normandy or Guam within months, all using the same spare parts and training manuals. August 1, 1944, Normandy, France. At Isigny-sur-Mer, the 3rd Armored Division unloaded tanks directly from landing craft onto French soil. Each division operated 232 Shermans, backed by 76 half-tracks, 54 M10 tank destroyers, and a network of mobile repair depots. The division's fuel train, 600,000 gallons per day, followed by sea and truck from Cherbourg. This combination of steel and supply created unstoppable momentum. In 1 week of operations during the Normandy breakout, 3rd Armored advanced 75 miles, burning through 1.2 million gallons of fuel and losing 98 tanks, all replaced within 48 hours. German commanders described the Allied advance as endless armor. They destroyed tanks by the dozen. Replacements appeared by the next morning. October 1944, Leyte, the Philippines. Half a world away, another convoy landed 54 Shermans with the 44th Tank Battalion under the 1st Cavalry Division. These tanks fought in rice paddies and jungle trails, against Japanese Type 95 Hagos and Type 1 Chihis. The result was not a battle but an industrial mismatch. Japanese shells bounced off the Sherman's glacis. Its 75mm gun shredded enemy armor at 1,000 yards. One of those Shermans was knocked out by a magnetic mine and captured intact. It would be disassembled, packed in crates, and shipped by freighter to Yokohama, then trucked to Tachikawa Arsenal. By the end of 1944, the Sherman existed on every major front: Europe, Africa, the Pacific, even Burma and Italy. It was the only tank in history to fight under 5 flags: American, British, Canadian, Soviet, and Free French. When Japan's technicians began their inspection that December, they were not merely studying a vehicle. They were studying a system, one that united industry, logistics, and doctrine into a single repeating act of power. The next year would test that system in Europe's fiercest armored battles, where the Sherman would face Germany's deadliest machines head-on. June 6, 1944, Normandy, France. At 6:31 hours, the first M4A1DD Shermans of the 13th/18th Royal Hussars hit the surf off Sword Beach. The sea was rough, 4-foot waves, wind at 20 knots. Of the 40 tanks launched, 31 reached shore. Their canvas screens folded down, water drained from the bilge pumps, and the Shermans opened fire within minutes of landing. Across 5 beaches, the Allied invasion force fielded 4,126 landing craft, 6,939 ships, and 1,213 warships. Amid that vast armada were 656 Shermans, amphibious, flail, bulldozer, and command variants. By nightfall, most had cleared the beach exits, firing point-blank into concrete bunkers. The Sherman had evolved into a tool set, not a single machine. Some mounted mine flails, the crabs, others flamethrowers, crocodiles, or floating skirts. The common frame meant parts could be swapped between any model. June 8, 1944, near Tilly-sur-Seulles. 2 days after D-Day, the Panzer-Lehr Division, one of Germany's best, counterattacked. The Sherwood Rangers Yeomanry met them with M4A1s supported by Typhoon fighter bombers. The Germans fielded Panther OSF. GS, 45 tons, 75mm KWK-42L/70 gun, frontal armor 80mm, sloped 55 degrees. At 1,500 yards, a Panther could destroy a Sherman with a single hit. The Sherman's 75mm gun had to close to 600 yards to penetrate. The disparity was brutal. In the first hour, the Rangers lost 12 tanks. Yet by the day's end, the German counterattack stalled. Allied artillery, fighter bombers, and endless reserves turned the fight. Lieutenant Stanley Christopherson, commanding A Squadron, wrote later, "For every tank we lost, another was already coming up the road. That was not exaggeration. Each U.S. armored division in France had 76 replacement Shermans in mobile depots. Damaged tanks were recovered, repaired, and returned to service within 72 hours. June 26, 1944, Villers-Bocage. In Normandy's hedgerows, visibility dropped to 50 yards. Tanks fought ambushes, not battles. German Tiger I tanks under SS Hauptsturmführer Michael Wittmann ambushed the 7th Armored Division, destroying 14 Shermans in 15 minutes. The encounter shocked Allied commanders. But instead of halting, they adapted. Engineers devised the Rhino device, welded steel prongs that cut through hedgerows. Within 2 weeks, 60% of Shermans in Normandy carried them. The tank regained mobility. Simultaneously, the new M4A376, WHVSS, nicknamed the Easy 8, entered combat. Its 76mm M1A1 gun could penetrate a Panther's side armor at 1,000 yards. Its horizontal volute spring suspension gave smoother ride and stability for accurate fire. Crews painted their turrets with chalk kill rings, not bravado but relief. By July 31, 1944, Operation Cobra shattered the German front west of St. Lo. The U.S. First Army advanced 60 miles in 4 days, losing 183 Shermans, but destroying or capturing over 350 German tanks and assault guns. For the first time, German command reports used a new term, tactical paralysis. The Allied system, tanks, fuel, air power, and replacement, was now self-sustaining. August 8, 1944, near Sinthos, Normandy. During Operation Totalize, the Polish 1st Armored Division faced the SS 12th Panzer Division Hitlerjugend. In one day 96 Shermans were hit, 38 crews lost. Yet the advance continued. The next morning replacement columns rolled forward. 104 tanks from the second echelon. For the Germans each loss was irreplaceable. By August, the Wehrmacht had fewer than 200 operational Panthers on the Western Front. The Americans had 6,000 Shermans in France alone. The tank that Japan's engineers would later study had already fought through these fields. Its armor might be thin, its gun outmatched, but it was everywhere, always repaired, always returned. By September 1944, Allied tank losses in Normandy totaled 4,102, but over 5,000 new Shermans had arrived through Cherbourg and Omaha's artificial harbors. Logistics had beaten design. In Tokyo, Major Ishikawa's future report would describe the Sherman as an inferior tank that wins wars. He wasn't wrong. But the story was not finished. In Europe, the Sherman now rolled east toward the Siegfried Line, and in the Pacific, it was preparing for the final island battles that would carry it to Japan's doorstep. June 15, 1944, Saipan, Mariana Islands. At 7 o'clock hours, the first M4A2 Shermans of the 4th Marine Tank Battalion rumbled ashore. The landing beach was narrow, littered with wrecked Amtraks and burning palm trees. Japanese machine guns from Hill 500 cut through the surf. The Shermans crawled forward, 32 tons each, diesel-powered, their tracks churning coral sand. Behind them, Marines followed in the tank's wake, using the steel hulls as moving cover. Ahead lay 30,000 defenders of the 43rd Division under Lieutenant General Yoshitsugu Saito. By midday, the Shermans reached Charan-Kanoa airfield. There, they met the Japanese 9th Tank Regiment, 44 Type 97 Chiha and Type 95 Hago tanks. The Chiha's 57mm gun fired first. The rounds ricocheted off the Sherman's glacis at 600 yards. The Shermans replied. Their 75mm shells burned through the Japanese armor in one hit. The duel lasted 14 minutes. The 9th Tank Regiment ceased to exist. But victory came at a price. Japanese infantry swarmed from spider holes with magnetic mines and Type 99 grenades. In one day, 10 Shermans were disabled by close-quarter attacks. Crews learned to keep hatches locked, machine guns loaded, and infantry close. By July 9, after 25 days of fighting, Saipan was declared secure. The Marines had lost 216 tanks and Amtraks. The Japanese lost all 44 tanks and 27,000 men. In the Pacific, armor was not about dueling, it was about persistence. February 19, 1945, Iwo Jima. At 8:59 hours, waves of landing craft approached the black volcanic sand of Red Beach 1. Each LST carried 5 M4A3 Shermans, equipped with deep wading trunks and spare track links welded to the hull for extra protection. When the ramps dropped, several tanks bogged instantly, their treads digging into sand too soft to bear weight. Others made it ashore, flamethrowers mounted in their turrets. The Marines called them M4 or Zippos. The Shermans moved up the beach at 4 miles per hour, firing at pillboxes dug into the slopes of Mount Suribachi. Japanese defenders waited until the tanks passed, then fired 75mm Type 90 guns into their rears. Crewmen bailed out under fire, some burning alive inside the steel hulls. By the third day the Marines changed tactics. Shermans advanced in pairs, one covering the other. Engineers followed with satchel charges. The tanks became mobile bunkers, flamethrowers clearing caves at 30 yards. March 3, 1945. After 2 weeks of fighting, 16 of 30 Shermans on Iwo Jima were destroyed. But the survivors had burned through 60 enemy positions and opened the path to Suribachi's base. April 1, 1945, Okinawa. The largest amphibious assault of the Pacific War began. 458,000 troops landed, supported by 800 naval vessels and 254 Shermans of the 713th Tank Battalion and 6th Marine Division. Here the enemy was dug into limestone ridges and cave fortresses. The Japanese 32nd Army deployed 120 tanks, most hidden as static guns. Their new weapon, the Type 147mm at gun, could penetrate 65mm at 500 meters, barely enough to pierce a Sherman's side. Crews learned to angle hulls, fire smoke and coordinate with Navy gunfire spotting teams. Every mile forward cost lives. The Shermans climbed Sugar Loaf Hill, Shuri Ridge and Conical Hill, burning caves one by one. By June 21, 1945, Okinawa was declared secure. The U.S. had lost 149 Shermans. Japan had lost all armor and over 100,000 troops. When the surviving Shermans were loaded for maintenance in the Philippines, Japanese intelligence agents noted every detail. One disabled tank, registration USA 3041733, was shipped to Yokohama under secrecy. It would become the specimen that Major Ishikawa and his team examined at Tachikawa Arsenal 6 months later. By then Japan had no fuel to move its own tanks. Its foundries lay silent. The Sherman they studied represented an enemy they could no longer match. A machine that embodied what Japan could never industrialize: consistency. In Tokyo's labs they measured, recorded, and tested every bolt. What they discovered next would force them to admit, quietly, that victory was not built from armor thickness. It was built from systems thinking. December 12, 1944, Tachikawa Arsenal, Tokyo. The American tank arrived in crates, 37 of them, shipped from the Philippines aboard the transport Nippon Maru. The labels were stenciled in English. U.S. Army Medium Tank M4A3, Ford Motor Company, Dearborn, Michigan. At 8 o'clock hours, technicians of the Army Technical Bureau began reassembly inside Building No. 7. The lead investigator, Major Kiyoshi Ishikawa, logged the process in precise handwriting. Examination of captured enemy armored fighting vehicle. Objective: determine principles of construction, mobility, and tactical employment. The Sherman rose slowly from its parts. Suspension first, then hull, then turret. By December 17, the machine stood complete again. Its olive paint still bore the faded white star of the U.S. 44th Tank Battalion. Bullet scars pitted the sides. The 75mm gun barrel was bent slightly at the muzzle, a souvenir of Lady's muddy terrain. But it was intact. The team divided their study into 4 categories: armor, firepower, mobility, and communication. Armor. Japanese metallurgists cut samples from the glacis and turret. The plates were rolled homogeneous steel, not face-hardened. Hardness averaged 270 Brinell, ductile enough to absorb impact without shattering. Ishikawa's report noted, enemy employs lower hardness but greater thickness. Our design, by contrast, is hard but brittle. Result: cracking under stress. The welded seams impressed the engineers. Unlike Japan's riveted Type 97s, the Sherman structure distributed shock evenly. Rivets, they admitted, often became lethal projectiles inside Japanese tanks upon impact. Firepower. The M375mm gun was examined next. It was straightforward: monoblock barrel, semi-automatic breech, hydropneumatic recoil. The Japanese 57mm equivalent had half the muzzle velocity. The Americans had sacrificed some penetration for reliability, using APC-BC rounds at 2,030 feet per second, effective against medium armor but easy to manufacture. The real surprise came when technicians examined the gyroscopic stabilizer. The device, a 25-pound gyroscope connected to hydraulic controls, kept the gun steady while the tank moved. No Japanese design had attempted such a system. Ishikawa wrote, Even if precision low, psychological effect on gunner significant, can fire on move. Mobility, they stripped down the Ford GAA V8. It was a 60 degrees all-aluminum engine with dual overhead camshafts and 4 valves per cylinder, a marvel of mechanical simplicity adapted from an aircraft prototype. Power output, 500 horsepower at 2,600 revolutions per minute. Japan's most powerful tank engine, the Mitsubishi Type 100, produced 240 horsepower. When they tested the transmission, it shifted smoothly through 5 forward gears. Lubrication was automatic. The entire powertrain could be removed as a single module. Ishikawa noted, field replacement time estimated at 4 hours. In Japanese service, a similar repair required 3 days. Communication. Inside the turret, they found the SER 508 radio, crystal-controlled, operating between 20 to 27.9 MHz. Range, 5 miles. Voice clarity exceeded any Japanese field radio. Every tank in a U.S. platoon carried one, allowing coordinated fire and maneuver. The Japanese equivalent, the Type 94 Mk4, had a range of 1 mile and often failed under vibration. By December 27, the investigation concluded. The findings were compiled into a 43-page report titled, Examination Results of Captured American Medium Tank. Only 10 copies were printed. The summary paragraph was stark. This vehicle's construction reveals no extraordinary invention. Its superiority lies in uniform manufacture, interchangeability, and practical maintenance. The American system allows mass field repair and tactical cooperation at a scale unattainable to the Empire. The report's closing line bordered on concession. Our tanks are built by craftsmen. Theirs are built by process. The process wins wars. When Ishikawa presented the findings to the Army Ministry in early January 1945, a colonel asked if Japan could build something similar. Ishikawa answered without hesitation. We do not lack skill. We lack steel, oil, and time. By then, B-29 bombers were already reaching Tokyo. Japan's own tank plants at Sagami and Osaka were shutting down from air raids and fuel shortages. The Sherman on display at Tachikawa was quietly moved to a shed for safekeeping. It would never run again. But its lessons were clear. Japan's defeat was not written in tactics or bravery, it was written in industrial mathematics. August 30, 1945, Tokyo. 3 weeks after the Emperor's radio broadcast ended the war, the warehouses at Tachikawa Arsenal stood silent. The captured M4A3 Sherman, once the centerpiece of Japan's technical investigation, now sat half-covered in dust. Its paint had dulled to olive gray. On its side, the faded white star seemed almost symbolic, the mark of a system that had crushed empires not through armor, but through organization. Major Kiyoshi Ishikawa walked the hangar one last time. Around him, crates of blueprints, metallurgical samples and technical drawings were stacked for destruction. Under the surrender terms, all classified studies were to be surrendered to the Allied Technical Intelligence Unit, ATIU. Before the crates were sealed, he added one final document, Gokaku 121, Summary Report on Captured M4 Medium Tank. The Allied analysts would read it weeks later and be stunned by its precision. The Japanese engineers had dissected the Sherman with scientific rigor, identifying the very factors that defined the American war machine. September 5, 1945, Yokohama Dockyard. An ATIU transport truck unloaded the same Sherman, USA 3041733, now reassembled for Allied review. American officers from the 9th Ordnance Group inspected it side by side with the Japanese report. They noted how accurately the measurements matched U.S. factory specs. 63 mm glacis at 56 degrees, 75 mm gun M3 with 38 degrees traverse, 500 horsepower at 2,600 revolutions per minute. One intelligence officer underlined a single line from the Japanese conclusion. This tank is not the strongest nor the fastest, but it is the most sustainable. That word, sustainable, captured what many military thinkers missed. The Sherman was a system, not a machine. From 1942 to 1945, the United States built 49,234 Shermans, an average of one every 30 minutes. Each could share parts with trucks, tractors, or other tanks. Supply officers could rebuild a damaged tank in the field using components shipped from halfway across the Pacific. Japan, by contrast, had produced fewer than 2,300 tanks total, most assembled by hand, each slightly different. Logistics became impossible. The Type 97's carburetors, tracks, even bolts required individual fitting. A single broken gear meant immobilization. The Sherman embodied something deeper than steel: interchangeability. The Japanese engineers had recognized it, and admitted it. October 1945, Allied Translation Section, Tokyo. Interpreters working through the Gokaku 121 file flagged several lines for special attention. One read: Enemy's weapon is mass coordination. Their tank is built for system warfare, fuel, parts, transport and communication unified. That analysis would later influence early post-war industrial studies. When Japan began rebuilding in the late 1940s, engineers from the former Tachikawa team joined emerging manufacturers, Toyota, Nissan, Hitachi. They carried the lesson they had learned from a defeated tank: process mattered more than perfection. Toyota's production engineers later cited wartime studies of foreign vehicles as foundational. The Toyota production system, Kanban, just-in-time, continuous flow, echoed the same philosophy Ishikawa had observed in the Sherman's modular design. The tank built for victory in war had quietly seeded the blueprint for victory in peace. 1946, Aberdeen Proving Ground, Maryland. The captured Tachikawa Sherman, repatriated to the United States, was displayed for ordnance students. It bore a small plaque. Recovered from Japan, 1945. Studied by enemy engineers, returned by history. Behind it, American instructors explained how the Sherman's balance, armor, mobility and firepower in harmony, had triumphed not by superiority in any one aspect, but through logistical dominance. For every Sherman lost, 3 more could be delivered. For every gun jammed, parts were waiting in the next convoy. By 1945, it had become clear: wars of the 20th century were not won by genius commanders or heroic charges, but by systems that never broke. The Japanese technicians who once prided themselves on fine craftsmanship had confronted a truth that would redefine their nation: precision was useless without repetition. Efficiency was meaningless without scale. And so, when they examined that American tank, built in an assembly line, tested by numbers, shipped across oceans, they saw for the first time the architecture of inevitability. They admitted it plainly in the final sentence of their report. The Sherman tank is not built to excel, it is built to endure. And endurance, multiplied by thousands, equals victory.